Hi everybody and welcome back to another audiophile production video for the old school fanatics. It's time for another amp dyno video of a smaller old school amplifier, American Warriors series, which was made by Hifonics, and this amplifier is rated by the manufacturer in two ways: 65 watts per channel into a form load and 90 watts per channel into a form load at 14.4 volts. I don't know when the amplifier was made, I guess in the early or mid 90s, I'm not sure. If you know more about it, let me know in the comments. Here on this side you can see the power LED is yellow and the diagnostic LED, which is red, which comes out if something is wrong with the amplifier. It has lots of filter adjustments. You can not only adjust the crossover frequencies or set the amplifier to high pass, low pass. The amplifier features cross shifts. That means you can adjust the behavior of the filter in the range of the crossover frequency. You can select the filter Q. Let's go to the amp dyno.
The Falcon is connected to the power resistors, and the first test is 8 ohms mono. That means I test 4 ohms per channel, both channels driven into full power. And the first test is continuous power test with 1 kHz, both channels driven. Oh, clipping. I got a peak voltage of 51.2 volts. With 51.2 volts, the amplifier puts out 84 watts of continuous power with 1 kHz into a form load per channel, both channels driven. And now let's have a look at the amplifier's efficiency. Here you see the idle current of around 0.8 amps. And now I give full power. The amplifier pulls 18.4 amps. I calculated an efficiency of 66.6%. And now the same continuous power test, but this time with a 50 Hz input signal. Oh, my signal looks a little bit bad. I will fine-tune the output signal. Now it's okay. Is it okay? I reduce the gain a little more. Doesn't look too pretty. I would say this is okay. And I have a peak voltage of 47.6 volts. With 50 Hz, the amplifier delivers 72.6 watts. Dynamically, with 20 cycles, I have no dynamic headroom. There is no increase in output power. I have 48.4 volts, all cycles at the same voltage level, and no clip signal. That means I have 75 watts of dynamic power into a form load, both channels driven into full power. So we have 8 cycles. And I have a little higher output voltage of 49.2 volts. That's 77.5 watts per channel into a form load of dynamic power with 8 cycles. Now I'm testing for just 1 cycle, that means 1 millisecond. Capturing 1, okay, it doesn't look too good, but it's okay, not heavy clipped. So this is just for fun. Let's calculate with 54.4 volts. That's around 94.8 watts into a form load, both channels driven into full power. It's a little bit weird that the dynamic power 8 milliseconds and 20 milliseconds is lower than the continuous power test with 1 kHz. I retest the 1 kHz continuous power test. Maybe I made a mistake. I had more than 50 volts in the continuous power test. There it is, but we still have more than 50.8 volts. So we have higher continuous power than dynamic power. In the first test I had 84 watts and now I have 82.7 watts. Now I switched the load to 4 ohms mono. That means I test 2 ohms per channel, both channels driven into full power. 1 kHz continuous power test. Capture the screenshot. and the peak voltage is around 43.2 volts. With 43.2 volts, the amplifier puts out around 119.6 watts into a 2 ohm load per channel, both channels driven into full power. Let's have a look at the efficiency. Here we have the idle current, and now I give full power. The amplifier pulls 30 amps. I calculated an efficiency of around 58.2%. Continuous power test, but this time with 50 Hz. Signal looks clean, and the peak voltage 40 volts. The amplifier delivers around 102.6 watts of continuous power with 50 Hz into a 2 ohm load, both channels driven into full power. Against my expectations, I reached just 119.6 watts. That's the same value like the continuous power test, so no dynamic headroom in this case. I go down to 8 milliseconds. Now I'm testing with a burst with 8 cycles. And we have a voltage of 44.4 volts. All cycles at the same voltage level. With 8 cycles test, the amplifier delivers 126.4 watts into a 2 ohm load per channel, both channels driven. Now I'm testing with just 1 cycle, that means the peak power for 1 millisecond. Doesn't look too good, but I will reduce the voltage. I'm not going to take the peak here. I take the top of the clipping line. So we have 50 volts. The amplifier delivers 160.3 watts into a 2 ohm load per channel, both channels driven.
Thank you very much for watching this video, and see you next time for another amp dyno video.